Hello everybody. Welcome to the video on classifying polygons. We'll get into what polygons are and classifying them. You'll get into what we mean. We're naming them and just going through here. Polygons and their pieces and parts. Concave and convex. Naming polygons. Equilateral, equiangular, and regular. We're going to go through all those things, what they mean, how we use them. As they deal with polygons. Okay, so let's go ahead and get started. First of all, a polygon, if we break down the word, poly means many, gon means side, so we are dealing with a many-sided figure. Now, if you remember from angles, when we had an angle, if we labeled the parts of this, we had a vertex and a side. Okay, well now we're just going to take a bunch of angles and build polygons. So we've got a side and a vertex here, and we're just going to keep making angles until it's closed, okay, to make a polygon. Now, if we look at our book, on page 42, there's a blue box. I'll read that blue box. In geometry, a figure that lies in a plane is called a plane figure. A polygon is a closed plane figure with the following properties, so it has to have these two things. It is formed by three or more line segments called sides. Line segments. Notice none of these are lines. Okay? And the segments, they all have to be straight lines. Each side intersects exactly two sides, one at each endpoint, so that no two ends with a common endpoint are collinear. Okay? So, if I take any 3 points, they are not collinear. Okay? And obviously these are not collinear. Let's go with a different color here. We'll use black. Point, point, point. Not collinear. Any 3 points. Okay? And the segments also intersect at the endpoints. Okay? Polygons don't look like this. Okay, they always intersect at the endpoints, and they all are line segments, and they have to be closed, always have to have straight lines. So basically here, and we're talking labels, everything's the same as an angle. Sides, vertex. Okay, check my time here, very good. Okay, closed, straight lines, segments have to intersect at the endpoints. Concave and convex. Okay, now, I'm sure you've dealt with this with mirrors. Okay, if you're dealing with a concave mirror, it caves in. And a convex mirror goes out. Correct? Well, the same idea is true with polygons, but maybe a little different idea. Okay? Think about it this way. If I had a string, okay, there's two different ways to think about this. Well, we'll do the string 1 second. If this figure right here were three-dimensional, if it were a prism, so if it looked like this, okay, and we've got something going here, okay, if I poured water straight down on top of this, and I can rotate it any way I want to. If I can pour water on that, and that thing will not hold water, it is convex. Convex. Okay? But if it would hold water, okay, like this one would, okay, if I poured water in here, if I rotated this a little bit this way, it would hold water right in there. Correct? It would hold water right here. I mean, this is, if this was like this, there's a little pocket there for it to hold water. That is concave. Okay? So polygons can either be convex or concave. That's one way to think about it. Another way to think about it, the way your book describes, is if you took a string and you wrapped a string as tight around that thing as you could, and let's say our string goes here. Okay? So we've got a little string here. And I wrapped it as tight as I could. If that string at any point does not touch the sides, it's concave. Okay, because see, the string right here doesn't touch this side. So that is concave. But if I do it to this square, if I string a string tight around here, and we'll do it right here, that string is always going to be touching the sides, correct? Always. So then it is concave. Two different ways to think of it, but figures can either be convex or concave. And those are two ways to think about whether they are convex or are concave or not. Okay? Naming polygons. All right. This is in your book. There's a chart on page 43. Learn these names. We will be calling things by these names. Hopefully you know some of them. A polygon with 3 sides, hopefully we all know, is a triangle. Correct? If you don't know that, you've been living in a hole. A 4-sided figure is not a square. Okay, a square is a special kind of this. 4 sides is a quadrilateral. It's a quadrilateral. Okay? A 5-sided figure is a pentagon. 6, hexagon. 7, heptagon. Okay? 7 sides is a heptagon. 8 sides. I think everybody knows this stop sign. Octagon. Oops, that's an A. Octagon. 9 sides. Nonagon. 9 is non. 10, decagon, like a decade, or decimeter. Decagon. We don't have a name for 11. 12 is a dodecagon. And n we will call an n-gon, and that just means that it's any-sided figure. So if I had 72 sides, we would call that a 72-gon. Okay? Hopefully that makes sense. Learn those names, because on a quiz I might ask, please draw me a regular nonagon, and you have to know what a nonagon is, how many sides that is. Okay? I will refer to things by their name, not by how many sides they have. Pentagon, hexagon, heptagon, nonagon, octagon, triangle, quadrilateral, and away we go. Okay, here we go. Next slide. Next slide. Equilateral and regular. Okay, equilateral, equiangular. Let's talk about this. Equilateral means that all sides are the same length. All sides are the same length. Okay? So, like a square, and if we showed that all sides are the same length with my dashes, that would be equilateral. Okay, if we look down here at this rhombus down here, all those sides are the same length, so it is equilateral. Okay, triangle here, equilateral. All these figures, except for this one, because obviously the way it looks, this side's longer than this side, are equilateral. These all look equilateral. These all look equilateral. Okay, and they have to tell you. Your book will try and trick you. They have to tell you it's equilateral. Okay? Just so you understand, all sides have to be the same for the figure to be equilateral. Equiangular, hopefully that makes sense. All the angles, in a square, they're all 90 degrees. All the angles have to be equal. Okay? All the angles have to be equal for it to be equiangular. Okay? Now, in this case, this is not equiangular. This rhombus down here, because the top angles are smaller than the side angles. Okay? So that is not equiangular. Okay? Now, for a figure to be regular, let's label everything here. So this is, equiangular is all angles the same size. Okay? Okay, now if I'm looking at regular figures, a regular figure means that it is both equilateral and equiangular at the same time. So in this case, this square is regular because all the angles and all the sides are exactly the same. This triangle is regular. Okay, this rhombus is not. It's equilateral, but it's not equiangular. Okay, so it is not regular. This rectangle is not. Let me use red here. Because all the angles are the same, but the sides are not. So that is not regular. For it to be regular, all the sides and all the angles have to be the same. Okay? Finally, that's it. That's it. We've been through it. Holy smokes, that was quick. That was quick. So let's review polygons, sides, angles, two restrictions. It's built by line segments, has to be closed. Okay, and the intersections of the segments have to happen at the endpoints, and no 3 points in a row can be collinear. Concave, convex, we talked about that. Whether it, like in this case, this would be a concave figure, or convex figure. Holy smokes. Convex figure. And if I were to draw a concave quadrilateral, this would be concave. Again, if I strung the string around there tight, it would not touch these sides, so it's concave. Naming polygons, we went through all the names: triangle, quadrilateral, pentagon. Learn those names. They're in your book as well. Equilateral means all sides are the same length. Equiangular means all angles are the same size. And regular means both of those at the same time. So all the sides are the same and all the angles are the same. It's equilateral and equiangular all at the same time. Okay? We will work with some homework on this both Friday and Monday. So if you have any questions, please bring them to class on Friday. And if you're in 7th hour, we don't have class on Friday, so we'll see you on Monday.